My name is Niels Leenheer. I'm the creator of HTML5Test, and I am a browser geek. HTML5Test, it's a website for testing web standards support. Basically, what you do is you visit the site of the browser, and it checks all kinds of APIs and features and what scores for each feature support. And it adds all those points up, and you get total score. And that total score is 555. Why 555? 555. It's HTML5 test. So the scores you get from HTML5 test. Well, they are supposed to say something about how well your browser supports standards, but they're not that interesting to me, actually. But I'll show the scores from the current desktop browsers before I start with my actual talk. As you can see, Chrome leads with 521 points, and at the bottom is Internet Explorer 11. And as I said, the scores don't interest me that much, especially differences like this, because basically every browser that scores around 400 points is a good browser and perfectly capable of browsing today's web. What I find more interesting is changes like this. Internet Explorer 6 versus Edge, and that shows that Microsoft actually has come a long way since IE6. So that's all about scores. My talk is about weird browsers. Weird browsers, what do I actually mean with weird browsers? Browsers and devices that do not adhere to current expectations. I have an example. 5 years ago, you had laptops and desktop computers, and you used mouse or trackpads. And you had phones, tablets, and used touchscreens. And you have events for both kinds of inputs. And if you check if a device has a touchscreen and use touch events, and otherwise use mouse events, well, 5 years ago that worked, but nowadays expectations have changed, and you can just connect a mouse to a tablet. If you listen to just touch events on the tablet, this is not going to work. So that's what I mean with expectations. Devices that do not adhere to expectations. Weird browsers. Are there actually any weird browsers left? Because mobile used to be all about weird browsers, but mobile is the new standard, and everybody builds responsive websites, and mobile is actually not that interesting anymore. Where can we find weird browsers? Well, for example, game consoles, or portable game consoles, smart TVs, e-readers, smartwatches. Smartwatches can run browsers. Photo cameras, cars. This is a photo from a Tesla S, which has a browser in its console. Full touch screen with a full browser. And well, I don't actually have a Tesla S in my device lab, so how do you test browsers like this? By the way, if there's anyone Anybody from Tesla here in the audience? Come see me after. Well, all of these browsers have something in common. Comparable with mobile before the iPhone and Android. Everybody is just trying something, and not everybody is succeeding. So we have browsers with a high level of what the fuck. Well, we can't look at everything today, but I'll start with just smart TVs, set-top boxes and consoles, which I all treat the same because they're basically just big screen browsers. And testing big screen browsers is also difficult because I have a smart TV in my home, but I don't have a whole bunch of them. So how can I test if my website works on not just a WebOS television, but also a Tizen television? Well, I went to the MediaMarkt. I asked them if I could test the browsers on their televisions, and they looked at me funny. It took some convincing, but finally they walked to a big drawer and handed me a remote, 5 remotes, and just said, go ahead. And I spent 2 afternoons at the MediaMarkt. And first of all, television browsers are actually pretty good. The last generation actually uses the same operating systems as mobile devices use, like Android or Firefox OS, Tizen or WebOS. And the scores on HTML5Test are also pretty good. Not as good as desktop browsers, but still pretty good. Consoles are a bit lower. Basically, that's because consoles, the last generation is already a few years old. And you can see a clear division between this generation and last generation, which is 5 years old. I went to the MediaMarkt and I tried loading just a few demo sites, and this is what happened first. Low memory and slow CPUs. That's basically what televisions have today. And better than a couple of years ago, but it's still not optimal. So what are the big differences between television browsers and desktop browsers? First of all, control. Control is the biggest difference, and it's also one of the biggest problems. How do you navigate without a mouse, trackpad, or touchscreen? You use a D-pad, which is basically arrow keys. Well, that experience is not that good. You basically you press buttons up and down and move to the next button and press OK to activate the button. And it's comparable to feature phones or phones without touchscreens. The experience is pretty bad. But it can be worse. You could also just move a mouse pointer with the arrow keys, and that doesn't work at all. There are a couple of alternatives. First of all, there's the analog controllers, for example, especially on consoles. And an analog controller is a bit like that red eraser head on the middle of an IBM ThinkPad keyboard. It already works a bit better. And we have remote with trackpads. We have remotes with air mouses, which work a bit like a Wii remote, or a Wiimote. You point at the screen, and if you move your hand, the cursor on the screen moves. And that works pretty good, except your arm will probably fall off after 10 minutes of browsing. And we have second screens. This is the Wii U gamepad, and you have a screen in front of you. Well, that's very nice, but why bother watching on a TV if you already have a screen right in front of you? Well, perhaps it is to show somebody in the room what you're browsing. So, okay. Many manufacturers also make apps for controlling the smart TV or console. And again, why then not browse on the phone itself? This is for the Xbox and for the PlayStation, and this is for LG WebOS television. Another problem, or another difference, text input without using a keyboard. Once again, the D-pad. And it is very clumsy. This is how you enter text with the D-pad. You just go from letter to letter and enter the URL, which is very irritating for long URLs. Not that quick. Alternatives. Remotes with keyboards. And people used to laugh at the enormous full keyboard remotes for the Google TV and compared it with the simple and sleek and minimalistic D-pad of the Apple TV remote. But for text input, this is actually much, much better. And what many people don't know, you can actually connect USB or wireless USB to most TVs or consoles, and they just work. And sometimes you even have a trackpad built into the keyboard. It actually works pretty good. And once again, we have apps. The Xbox, the PlayStation, and many more. And another way of controlling the screen is gesture control. And actually, supposed to work really good, but I recorded this earlier. I'm going to try to do the same things I did here on the screen. High five. Well, your arms will probably fall off after 5 minutes, and it really doesn't work. Okay, how can we control these inputs directly from JavaScript? We have mouse events, we have touch events, keyboard events. How about D-pad events or gamepad events? Might be useful for HTML games or something on the television. So, the D-pad, maybe. We can actually use keyboard events. And most of the time it works, but there's still a big problem. Key codes, which determine which key you pressed, differ between manufacturer and sometimes even between model. So you can't just listen for the up key. On another television, it might be a completely different key code. And another tip is use prevent default, because most remotes have default functions that you don't want to use if you use your own events. But unfortunately, that does not work on every device. So expect pressing the up key and you get your events, but then the browser also uses its own handling of the upkeep. It's not really ideal. The gamepad also it may be. There's actually an API for listening to the gamepad. It's the gamepad API. And it's supported on the Xbox One, on the PlayStation 4, on the Wii U, on the WebOS, and Tizen probably. I couldn't check Tizen because they wouldn't let me connect the gamepad to the Tizen television at the MediaMarkt. So the SDK says it's supported, but so does PlayStation 4 and the Wii U and the WebOS. But while they say they support it, if you connect the gamepad, it actually does not return any connected gamepads. The gamepads array here is empty. Only the Xbox One actually reports back the connected gamepads. So the PlayStation, basically what the developers of the PlayStation did was enable a feature in their rendering engine, but didn't add any back-end support for talking to the hardware. That's going to be the theme. The Wii U actually has its own API. Why bother using a standard? But it does work, so that's pretty good. The webcam, it's also a form of input, and we have an API for accessing the webcam. It's get user media, and it's only supported on the Xbox One. Well, not on the current Xbox One. Later this year, the Xbox One will get an update to Windows 10, and then Microsoft will support accessing the webcam. And gestures, well, no, but maybe in the future on the Xbox. I talked to somebody from Microsoft, and they alluded to looking at it, but there's no real clear plans. What are the differences between a television and a monitor? Well, the first thing is overscan. Due to historical reasons, the television will actually not show the borders of the image. It will enlarge the image a bit and crop it. If you have a built-in browser, it's not affected, but anything connected to HDMI is. So the television enlarges all the images from the HDMI input by 5%, and then chops off the borders, and that is the image you're looking at. And that also means that your beautiful 920 by 1080 pixel image will be enlarged a bit, and then you'll get blurry output. And that's clearly visible on the screen. So how do we deal with this? Well, there's a setting, it's called overscan correction. And most consoles allow you to change the overscan correction. And what it does is it uses extra black borders around the browser, around every image from the console. And when the image is enlarged, the black border will fall off, and the image is actually fully visible. That's a good solution, but still blurry. And not every television set enlarges the screen by exactly 5%. Can vary between different manufacturers, and even different models from the same manufacturer. There's a setting on most consoles that you can use to set the correct overscan for your system. There's always a problem also with overscan correction. The PlayStation 4 will always show the browser without overscan correction. So no matter what you do, even if you configure overscan correction on the PlayStation 4, the sites will fall off. There's another solution. it's called no overscan. You can actually change the setting of your television and turn off overscan correction. And sometimes it's called screen fit or pixel perfect, or just scan. And if you don't use an English television, sometimes you get very weird translations, because the Dutch WebOS television, which uses just scan, I don't know if it has anything to do with overscan, but the just scan is translated to jetzt suchen in German. And I don't know why, but even, just imagine, can your parents find this setting on their television set? And do they know what it does when it is jetzt suchen? Okay. Again, there's a problem, and ironically, it's again on the PlayStation. The PlayStation 3 always uses overscan correction. Because if you turned off overscan on your television, you will always get borders around the browser on the PlayStation 3. PlayStation 4 never uses overscan. PlayStation 3 always uses overscan. It's... Okay. The viewport. There's a book created by PPK, Peter Paul Koch. It's called the Mobile Web Handbook, and it has a very good explanation of the viewport. I'll just quickly try to explain the concept of the two viewports. First of all, there's the visual viewport. It determines what part of the website is visible. And we have the layout viewport, and it determines how wide the site is rendered. And if you change the width of the layout viewport, you actually get a different rendering, at least if you use responsive design. There's the layout viewport and the the default viewport, the default layout viewport, is different on every smart TV, console, or set-top box. On mobile, it's usually between 980 pixels, and on desktop, it's the width of the browser window. But on the television set, it's between 890 and 20 pixels. So on different browsers on the television, your website will look completely different. It's possible to change the width of the layout viewport with the meta viewport tag, and that works perfectly on mobile. So instead of the default 980 pixels, you get the same layout viewport as your device, which most phone apps or web apps use, or you can set your own value. Works perfectly. Once again, problems. Meta viewport is not supported on television browsers. So there's no way you can get the same layout viewport in different television browsers. So what are you going to do now with your more beautiful responsive design website? There's another complication. Device pixel ratio is also not supported. And what you usually get on smaller layout viewports is that one CSS pixel consists of multiple device pixels. Just like an iPhone, which has a width of 320, the original iPhone, a width of 320 pixels, CSS pixels, but 640 device pixels. So each CSS pixel consists of two device pixels wide and 2 device pixels high. So each CSS pixel is actually 4 device pixels. So we want 2x or retina images. And that does not work on television browsers. So we have low resolution images. And how do these differences look like? I've created a couple of screenshots. This is the Nintendo Wii and the Wii U, WebOS, Google TV, Xbox 360, and things you can see things are getting smaller as the viewport width increases. Netcast, PlayStation 3, and PlayStation 4. So basically all over the place. One more thing. Device pixels are not always device pixels. Sometimes device pixels are not actual physical device pixels, but virtual device pixels. And for example, on Samsung 4K television or Panasonic 4K television, they render the content in regular HD and then upscale to 4K. And Samsung Android TVs render it in 720p and upscale to 1080p. And the Wii U resolution is the same as the little screen on the gamepad, which is then upscaled to HD. And the PlayStation TV, which is basically a PlayStation Vita without a screen and without the actual built-in controls. And it renders on the same resolution as the screen as the Vita. Another difference, distance to the screen. Make fonts and graphics on the site larger to account for viewing distance. People sit proportionally farther from TV than from a computer monitor of the same size. And that's really good advice. It's if you make websites that are supposed to be readable on television sets, you should make text and images 2 times or maybe even 3 times bigger. And how can we do that if we have all these different kinds of viewports? Well, the reverse of responsive design, fluid design, is basically the same layout on widely different viewports. The size of the content is determined by the width of the viewport, and we can use that pretty easily by using percentages for positioning. This works on small viewports and big viewports. It doesn't matter. 60% is the same width on a small viewport as on a wide viewport. And we can change the font size based on a fraction of the width of the screen. So text will automatically get bigger on larger viewports. And we could use viewport units, which are even better if they are supported, but there's a polyfill, so you're probably gonna need it. And of course, we need to make sure we have safe margins around the contents because we don't know how the user configured it overscan. There's actually some sites that use these principles and they work pretty good. One example is the YouTube TV website. And you can try it in your regular browser, youtube.com/TV, and it changes the layout completely for television. So how can we identify smart TVs? Because we want to give them special CSS. Well, we could use media types. Media TV. Should work, right? No. All televisions use the media type screen, just like regular browsers and mobile browsers. We could use the width and the height of the screen. Well, no. Like I said, there are many different viewports, so many different screen sizes. And many tablets or mobile phones or monitors also use HD resolutions. So having a 1080p screen says nothing about the device you're using. You could use user agent sniffing, which is pretty bad, but also doesn't work. there's no universal tag in the user agent string which identifies it as a television. And this user agent string is a television browser. How do we know it? If just looking at the user agent string, it's Safari on Linux, which is already weird, from Korea. It's actually an LG Netcast television. So, what can we do? Well, go back 10 years or 5 years, make 2 different websites. Yeah. Or perhaps you can build a button that enables couch mode and sets a cookie or something like that. And if the cookie is detected, you add extra CSS for the television screen. And it is actually pretty handy because you can also use it on your laptop. And if you connect your laptop to a television, it also works. That's probably the best method right now. Number 4, be careful with feature detection. And basically every feature that talks to the operating system or hardware is suspect. It's something I said on my blog last week, talking about the problems with feature detection. And it is something that is really a theme with television browsers. You can't trust feature detection. And I'm going to give you an example, geolocation. This is simple code for geolocation. We have a feature detect, detects the geolocation API, we call the API, we have success callback, and we have failure callback. And we have alternative content. Well, forget about the alternative content. Just look at this piece of code. Pretty simple, right? What can go wrong? How many ways this can go wrong? Actually, 4 ways. First way is not that bad. The failure callback is called with a permission denied error code or location not found error code. It doesn't ask the user if it's permitted to use geolocation. No, it just fails immediately. Well, as long as it fails, right? We can handle this. This is actually on a PlayStation TV or an Xbox 360, on a Samsung television from 2014, LG Firefox OS television, all use this method of giving us locations. There's actually a far worse way of failing, and it's basically no callback at all. So the user just waits and waits and waits till a location is found, but never finds one. And that's something Sony Blu-ray player did with Opera devices and what my own web OS television from LG did. This is actually a problem, and we can handle this by setting a timeout and waiting 10 seconds before a location is found and then fail. Yeah, workaround. There are 2 more ways. First of all, success is called, but with longitude 0 and latitude 0, which Python did and is not very helpful. But there's one more, and that one is almost comically broken. It's the Google TV set-top box, and it actually gave actual coordinates. Just the coordinates of Mountain View, California, near Google's headquarters, which also isn't very helpful. And this is just one example, and there are many more APIs. You get user media, get gamepad API, and many, many more. They're all problematic. So that's smart TVs. Yeah.
That's a question or
at the end. Yeah. Next topic. E-readers. e-readers have browsers. They score quite a bit lower on HTML5Test. That's expected because they don't have video support and audio support, and so they have a lower score. That's okay, I guess. What are the differences between a regular browser? The infrared touchscreen, for example. We know capacitive touch, we know resistive touch, infrared touch. It actually works by a number of LEDs at one side of the screen and a number of sensors at the other end of the screen. And if you place your finger on the screen, the light ray is blocked and it knows where your finger is. It works. The resolution is quite a bit lower than capacitive touch because you have, for every pixel of resolution, you have to have a separate LED and a separate sensor. So perhaps if you move your finger on the screen, you won't be able to touch every pixel on the screen. 1 in 4, 1 in 6. But it works. And we actually support normal mouse events. Well, support is a big word because the Kindle and the Pocketbook, they support mouse events, but they coalesce them. If you press your finger down on the screen, it doesn't send an event. Once you release the finger, it sends both the mouse down and the mouse up at the same time. Okay. The Combo Glow actually works a bit better because they have actually separate mouse down and mouse up events. And if you move your finger, they actually send mouse move events. Very good. And Sony Reader is even better because it supports touch events. Well, touch events with one finger. But touch events, okay. But they don't sell the Sony browser, Sony Reader anymore, so we can forget about that one. We have just mouse events. And the e-ink screen, that's actually something that is also very important if you want to know about differences. Technology is pretty complex, but this is just a basic explanation. We have small microscopic balls with two-sided pigments. We have electrodes. And when we apply current to the electrodes, the balls will turn. And turn. So then we remove the current from the electrodes. The balls will stay in the same place. It's actually very good for battery life, but it's also very, very slow. And if you never used one before, you don't know how slow. It's phenomenally slow. I created a little video to demonstrate it. Yeah. So maybe those CSS animations and trivial things weren't such a great idea after all. One other thing, colors that look very differently on a color screen can look pretty much the same on a 16 shades of gray black and white screen. They're basically the same. So how can we identify e-readers? Because we want to give them special CSS. We want to change colors, turn off animations. Monochrome CSS media query. No, it doesn't work. Basically, the browser thinks it uses color screen. The translation to black and white only happens in the display controller. So the browser does not know it has black and white screen. User agent sniffing. there's no universal marker, but you can detect models, manufacturers, and that's pretty much the only thing we have. And finally, I want to talk about portable consoles. And there are basically two families, the Nintendo DS family and the Sony PlayStation family. And I'm not going to talk about PlayStation because it's pretty boring, it's too normal. I'm going to talk about the DS family. It has two screens. And that sounds more complicated than it actually is, because it's pretty normal. We have a dual visual viewport. And the bottom one is the primary, and it shows, it starts on the primary screen, and everything that is scrolled off the primary screen is shown on the secondary screen. And we only have touch control of the bottom screen. And don't try using the little pen on the top screen, that doesn't work. But it's actually pretty normal. And once again, I'm in video. It just scrolls to the top, and that's it. Position fixed, it too works. Fixed to the bottom screen, but as soon as you scroll to the top screen, it moves to the top screen, and it's works pretty good. And what you may not know is these devices are actually being sold because of their internet browser. MediaMarkt had a campaign just a few months ago, and it said big on the advert, better browser. And how many of you use this as a browser? Perhaps we don't, but maybe teenagers. Because it's something to take into account. Well, are there any weird browsers left? Well, I think so, yes. There are many more, and perhaps I have time to talk about it some other time. But right now, I want to leave you with this quote. It's from Jason Bixby. We cannot predict future behavior from a current experience that sucks. And so there is some hope that the current experience pretty much sucks. Thank you. Okay, questions?
What is the browser in the Kobo? Just wondering the other day.
Sorry?
What is the browser in the Kobo? What engine?
The browser in the Kobo, it uses a WebKit rendering engine. It's pretty standard rendering engine. I even think it is based off the Android web view. Kobo is, I think it's just a shell around Android 2.2 or something. Okay. Yep.
Have you looked into voice input speech?
Yeah, I couldn't get it to work.
That's actually funny because you tweet yesterday, the day before, I think. During the talk, Apple will probably announce a new Apple TV, which will make my talk outdated before it's over.
Yep.
And indeed, Siri in the new Apple TV, so you can talk to your TV.
It doesn't have a browser.
Yeah.
Can you talk to the browsers?
There's both. Nice.
Yeah.
Can you do browser detection using the feature detection and the type of work?
Yeah, you can do that.
Yeah, because maybe you can do that and then combine it with also having the TV selector. I think we did something like that with EA6, right?
Yeah.
We detected some bug and then we said, well, if you behave properly, we will also work.
Yeah. But I have a whole lot of visitors on the HTML5Test website, and basically it does just that. it creates a profile of the browser, and from that profile, I can pretty much tell which browser we are using. So it is possible, but it's
It will also be
every day a new browser gets launched that is not known to our big database of browser profiles. So.
It will also mean it will be hard for people at Google to use their geolocation. Like one time it's correct. So, do you think that like supporting every input device with a separate API is the way to go? Because it sounds like, to me, it sounded it would be really scattered, like you have right now, that some browsers just decide to support some input devices.
Yeah, supporting, creating an API for every type of input. Well, sometimes different types of inputs can be mapped onto the same API. For example, remote controls and keyboards are pretty much the same. They could work with keyboard events, no problem.
The same with scrolling, right? Like you did with your gesture, like scroll the page.
They could translate that to mouse events.
Right.
Yeah. Probably better use a pointer events API, which supports mouse events and touch events and has hooks for other events. So it could probably get pushed into that. But right now there's no API at all.
Yeah, right. So instead of like having a mouse API, wouldn't it make sense to have a scroll API?
A scroll API. I think they are working on something with, it's called Scroll Compositor or something like that.
Right.
And of course that works. But right now you could listen to the scroll events and use your gestures like that. But any more questions? Thank you.
So I have a few minutes